Alright. Tuesday, December 20th. Yes, I have to double check each time. Alright. Sorry, I just took a toke of some good weed. Today is Tuesday. No, Tuesday in Spanish is martes. Martes in Latin, well, in Spanish, martes came or originated from, in Latin, Mars. So today is Mars Day. It's a religious Babylonian day in worship. Okay, so quantum vacuum, the quantum vacuum. I wanted to bring this up because I'm gonna explain where all this came from. Well, first let's look up dark energy. Excuse me. Okay, so dark energy is a hypothetical form of energy that exerts a negative, repulsive pressure, behaving like the opposite of gravity. It has been hypothesized to account for the observational properties of distant type supernovae, which show the universe going through an accelerated period of expansion. That is the whole expansion thing. That's absolutely debunkable. Why I could debunk that later on. We'll move into that later on. But we're just gonna get started with this whole dark energy thing. So right off the bat, we see that dark energy is a hypothetical form of energy. So it's hypothetical. That means it's made up. That exerts a repulsive pressure, behaving like the opposite of gravity. Again, gravity is also made up. A repulsive pressure. Okay, so pressure always has to be contained. So I mean, this is pretty dumb, but okay. So let's move a little bit forward on this dark energy. Oh, you know what? Here we go.
Take it for granted that our universe contains planets, stars, and galaxies, because those are the things we see. But the only reason these big structures exist is because of the nature of nothingness, empty space. But to understand why, we have to go back to the beginning, the very beginning, the Big Bang. You know, I always thought that in the Big Bang, the observable universe started as a point and then just expanded steadily, more or less, to the point that we're at today. But that's not actually how it happened. There were 4 different phases in the universe's expansion. To start, it was expanding steadily. But then, after just a tiny fraction of a second, the expansion just blew up, and the whole universe increased in size by like 10 to the 26th times in a very short period of time, and that period is known as inflation. And then, just as abruptly as it began, inflation stopped. And after that, the universe continued expanding, but at a decreasing rate. So the expansion of the universe was actually slowing down, which is exactly what you expect if the universe is full of massive objects that gravitationally attract each other. But then, about 5 or 6 billion years ago, the expansion of the universe started speeding up again. And this is thought to be caused by dark energy, an energy tied to space. So before that time, there was enough matter, the matter density was high enough, that it was pulling everything back together, slowing down the expansion. But once the universe reached a critical size, well, then there was enough dark energy to start pushing things apart. And that is the phase that we're still in. The expansion of the universe is accelerating. Now, this story doesn't really explain the formation of galaxies until you tie in the nature of nothingness. Now, ordinarily, we think of everything around us as made of particles, of atoms and electrons, but our best theories of physics are actually field theories that say all of these particles should be seen as just excitations in fields. The word field always gets me because it makes me think of, well, fields. But a field is just something that has a value everywhere in space. So every subatomic particle has its own field. An electron field, an up quark field, a down quark field, a neutrino field, and so on. And anywhere there's an excitation in this field, that is some energy in the field, well, that is where we will observe particles. So out in completely empty space, well, the values for all of these fields are basically zero. But here's the thing. It's impossible to make a field perfectly flat and zero.
You cannot take a quantum field and make it completely quiet. You know, it's the Heisenberg uncertainty principle. It says you can't take a particle and pinpoint it to exactly zero energy. Likewise, you can't take a quantum field and make it exactly flat everywhere.
Now, this is important because ordinarily these fluctuations are really, really tiny and they only affect subatomic processes. But during that period of inflation, the universe expanded in size so rapidly and so incredibly that those tiny fluctuations got blown up to the scale of the observable universe. Now, without them, we think the matter distribution in the universe would have been completely homogeneous, completely uniform. And that means the gravitational force on any object in the universe would have been the same in all directions, which means nothing would ever have collapsed into the big structures that we see today. But thanks to these fluctuations, there were slightly denser and less dense regions, and of course the denser regions had stronger gravitational fields, so they pulled in the matter from around them, and that clumped together the matter into huge gas clouds that would go on to be the galaxies that contain the stars and the planets and the things we know today. You can actually see the imprint of these quantum fluctuations in the leftover radiation from the Big Bang, the cosmic microwave background radiation.
The quantum fluctuations in the fields were amplified to big classical fluctuations in the density of matter from place to place. And those fluctuations in the density of matter show up in the universe today as temperature differences in the cosmic background radiation and ultimately in things like stars and planets and galaxies.
I think it is incredible that without these fluctuations in the vacuum, these tiny insignificant things that we take for granted, our universe might really contain nothing. Nothing of interest, anyway. Speaking of the vacuum...
Wow, that was totally stupid. Well, we'll come back to that. Okay, so let's take that in mind. Let's go back to dark energy real quick. So dark energy is a hypothetical form of energy that exerts a negative repulsive pressure, behaving like the opposite of gravity. Okay, so right off the bat, gravity is something we've already gone over this. If you've followed my channel, and you've gone down and you've seen that I actually read out the Principia from Isaac Newton, which he wrote, his words as translated into English, and it's a lot of God. Basically, God is the creator of everything, and without God made gravity, and gravity. So they're talking about gravity, which came from literally a Jasut. I mean, before the Jasut, I mean, like literally, like this is insane. Like they're taking this from Isaac Newton, and I read the Principia, or I like to call it the Principia first. I don't know, I like it better. So bear with me. So yeah, the Principia. I've read out the Principia to everyone on not only on YouTube, but it's been years that I've been reading that. Like I've explained to everyone, I used to be a hardcore Newtonian. I always hated Einstein, but I used to be a hardcore Newtonian. So anyways, so they're bringing up this this gravity thing, you know. So gravity is a religious concept. All right, it's basically according to Isaac Newton, gravity is the signature of God. That's like his thing. That's letting us know how intelligent he is. He made gravity and put everything in motion. Because gravity, in order for gravity to be real, everything had to be set in motion. It couldn't have been done just, according to Isaac Newton, it couldn't have been done by chance. It had to have been done by an intelligent creator according to the Principia. So, having said that, and having the math, the problem with Newtonian math is that after you get to I think the 13th zero beyond the decimal point, it starts creating infinities. I'm not sure if it's the 13th or I can't remember right now. You'd have to look that up on exactly how many decimals there. But the point is, sooner or later, the math starts failing for Newtonian math. So having, let's keep all that in mind. And like I said, the whole expansion thing, I'll touch a little bit on that. But as of now, we see that it's totally hypothetical. It's made up. And we can see there's just the imagery. A lot of the imagery will show this view would be like us standing and looking at it from the side. But if you were to stand from the top and look down, you would see it. It basically would be a pancake that's just spreading out more and more. As you can see right there, this trumpet-like form. So basically, the top is the disc. That's the circle. Okay. The problem with all of this, geometrically speaking, that's a plane. That circle is a circle plane. And as you can see, there's an edge to it. That's how you know it's relatively expanding. Right? And of course, there's different models, and you can see dark energy and the fate of the universe. This is totally, you're like, so let's move more back then. So we see that this darkness came from this whole concept came from somewhere, right? Someone must have thought this up, right? It's not like you woke up one morning and all of a sudden it magically was in everyone's books, in all the schools. Okay, so let's get rid of that. So, let's go to the beginning. And I know everyone's like, wait a minute, Simon, that doesn't make sense. You're going to something biblical. So as we can see, in the beginning there was darkness. Genesis. In the beginning, God created heaven and earth. Okay, and the earth was a waste and a void, and the darkness was upon the face of the deep. Okay, the light shines and the darkness has not overpowered. So that's in John. You guys have to remember that we're not going to focus right now on the New Testament. What we're focusing right now is the Old Testament, because the New Testament is a totally different story. The Old Testament is what we're focusing on because we're looking at the beginning. Now I know a lot of you are like saying, Simon, how'd you go into the Bible all of a sudden when you're supposed to be doing science? Well, a lot of you have already seen that I've explained and I've also posted proof that literally our school indoctrination system on every place, like every continent, the Jesuits went out of their way to get this indoctrination. They are the leaders of indoctrination, the fathers of indoctrination. They are the creators of, not the creators, but the masters of indoctrination. Literally the masters. That's why you have a master's degree, because this system was established by the Jesuits. I'll go ahead and look it up real quick. Universities created by the Catholic Church. Oh, my bad. So, did the Catholic Church invent universities? As you can see, in Europe, most universities with medieval history were founded as Catholic. And you can go over and over. Harvard, literally, this goes all the way back, you guys, believe it or not. So the Catholic Church knew that the best way to gain power is by indoctrination, and by that I mean indoctrination of the young. So the whole thing about schools and universities and having so this came from the Catholic Church, okay, you guys. So let's go back to this. So as we can see that the Jesuits actually are involved in the creation of the school system as we know it to be, because let's be honest, they're not going to ever admit that gravity's wrong. They're never going to admit, and I'll prove that right now, because I mean basically the entire system is based on these concepts. So darkness and light, I encourage, and I encourage everyone to look into it between the, what Jesuits have to say about darkness and light. But as you guys can see already, okay, in the beginning, there was darkness. Now, excuse me, a lot of Christians will cite or try to say, or look into the scriptures, into the Bible, and be like, well, the light was actually that God is light. But when they say that, they're actually speaking in terms of Jesus Christ, the Son of God. Now, according to old school the Genesis, God created light with sound. Okay, so when you look into the terms of creation, you have to think about anything that you create is your baby. I mean, I created that; that's my baby, right? So according to Jesuits, and not just Jesuits, but Hermetic teachings, and a few other ones, I guess the Rosicrucians, who else? Of course, the Masons. There's a few other secret, or not secret societies, but rather, how would you call them? Well, I guess you would call them secret societies, but they're not. It's not like that they're a secret, because we know that they exist. But they do secretive things, okay? But according to them, okay, and according, God's children, okay, God's first creations, His first creation will be sound, okay? God said, and then let there be light. Therefore, sound would be God's first son, or God's unseen son. It's not seen. And then God said, let there be light. So then, frequency is basically sound, because even most sounds we cannot see, we cannot hear, and most light we cannot see. Yet there's way more sound that we cannot hear, audibly detect, than there is light that we can visually see. Okay, do you guys understand that? So therefore, light, it would be the most beautiful son of God, the seen one, the one that's the most beautiful creation that God has made. Because that beauty, a lot of people, beauty comes from the eye. It's kind of hard to say that you find something beautiful when you don't have the option, when you don't have the when you don't have sight. When you physically do not have sight, for you to find beauty in something is a concept that a lot of people would not be able to wrap their mind around. Okay, so therefore we see that in the beginning there was darkness. Therefore, God would be the darkness, according to the whole Jesuit and Freemasonry and all that. Okay, I mean, I'm not gonna. I could easily be like, well, first of all, light and sound are both frequency. So, I mean, that just doesn't make sense to me. And me personally, knowing about how electromagnetism works, and how telecommunications works, and data and all of that, light and sound is not really real, according to what I know. Okay, but you can't say that it's a nothingness either, which is something that I'm trying to explain right here. Like this whole darkness and nothingness and this void is gonna you'll see as we move forward. Okay, so you see that the Jesuits, their main one of their main their main logos, not mean logos, logo as singular. For those that thought you could catch me on that one. So the logo and singular, they use the black sun. And the black sun goes back. I mean, there's like so much that you could. I again, something else I encourage you all to look, and not just the black sun, but just symbology in general, and not just in symbology, but look, this, the Rosicrucian, the Rosicrucian symbol is a geometric. It's not really an actual rose. I know they do use the rose that artistically, but they have actual logos where the cross, and there's the cross, and holding in the center of the cross is a geometric rose. It's like a rose of, yes, but it's a geometric figure. Now, if you've seen the other day, the other day that I went up there, the other day when I woke up early in the morning, the first one was at 3 o'clock to 5:30. And I recorded it. Actually, I didn't get good video, but around 5 o'clock, I got better video of not only Venus but Mercury. And then a couple days later, I again at 2 in the morning, I recorded both Venus and Mercury at 2 a.m. and both of them were pulsating. And you see that as the planets pulsate with their lights, you see these geometric symbols pop up as it pulsates, as it twinkles. A lot of people are like, yeah, it's twinkling. But if you look at it, if you zoom in and you look at the planets, you see that they're pulsating. As they're pulsating, they give off certain geometric symbols. There are probably, I don't know if anyone has looked up into cymatics. I totally encourage you as well to also look into cymatics. Go ahead and look at cymatics and then compare that to the celestial lights that we know as planets. So anyways, moving back, the black sun is there's like the black sun. Let me see, ancient symbol. We won't even look at ancient symbol. We'll just say black sun, Jesuits. Let's just go straight to the horse's mouth on this one. So the Jesuits, the Roman Catholic Jesuit order on the black sun of Saturn. Okay, there it is right there. That's on Reddit. People will look it up. But there's that symbol. IHS can mean lots of things. According to them, it means in hoc signa, which means in this land we conquer. The same crap that I don't know which one of the Roman emperors was going to war. I believe it was Constantine was going to war, and or no, it was Alexander the Great. I don't know, one of them. It was either Greek or no. One of the emperors back in the day was going to war, pulled out a shield. He had a vision, and it had to have been Constantine because that's when they unified Christianity with the Roman Empire. So it was Constantine, and he said he had a vision, and so they put a specific sign on their shield. And they went to war and they won. So that's where supposedly they get this from. Again, you can see that there's astrotheology. So the Roman Catholic Jesuit order and his black sun of Saturn symbolism, featuring the astrological glyph of Saturn, the monogram IHS for Jesus Christ, and 3 nails of crucifixion. Now again, like I said, there's also, supposedly they mean that it stands for Jesus Christ because of a famous painting. that said in Hoxigino on the top, as he's in it's a crucifixion scenario. Okay. However, there's also another hypothesis is it actually stands for Isis. What's the other? Set would be the S. Horus. Isis, Horus, Set. Which kind of makes more sense to me because of the whole set. So you would have sunset. The S stands for Set, which is the god of the sky. So sunset. That would kind of make sense. But anyways, we could go on and on about that. But I encourage you guys to look into this. It's really weird stuff. According to dark energy and gravity, there's hypothetically a dark black sun, which would be the binary twin to our sun, which a lot of astronomers, mainly Jesuit astronomers that look up into the sky night and study, astronomy, will tell you that most stars are binary, and so ours would be our binary sun would be a dark one. And so this is basically the study of darkness, and again how darkness created light. Now we can go off to dark matter. Dark matter is a hypothetical form of matter thought to account for approximately 85%. So when you then look up into the sky, they're like, oh, it's all dark. Well, what is that darkness? Well, it's dark matter. It's very simple. Okay, so black magic, you can look up black magic. You're like, wait a minute, that doesn't make sense. We're talking about dark energy. And I'm like, yeah, that's what we're talking about. So yeah, black magic, you can look up black magic. Black magic is also known as dark magic. Let's look at Wikipedia real quick. Also known as dark magic, has traditionally referred to the use of supernatural powers or magic for evil or selfish purposes, specifically the 7 magical arts prohibited by canon law. Okay, so that means so what they're saying right there is the Catholic Church knew about this darkness, this worship of darkness, and they banned it. So in order for them to be banning it, it's like, okay, well, they're most likely banning it because they themselves are practicing it, and they're prohibiting their own people, their own congregation, their own followers. They're prohibiting them from practicing practicing this black magic. Stand by. Sorry, got a little thirsty there. It's also referred to as the left hand path. So let's move back. We get another definition. Black magic definition. Let's go see what Oxford says about this. A type of magic which is believed to use the power of the devil in order to do evil. Okay? So it's a form of energy. It's a form of power. Well, that's the same one. Dictionary.com. Magic used for evil purposes, witchcraft, sorcery. Okay, so let's look up magic real quick. The power of apparently influencing the course of events by mysterious or supernatural forces. using magic or working by magic, having a parent super. Move, change, or create by or if as magic. That's basically the verb itself. Okay, the verb. Move, change, or create by or as if by magic. That's gravity. Furthermore, that's also dark energy. Okay? So, as we can see that, I'll go back to that. We'll go to Jaster on this one. Jaster's always good. So Albertus Magnus or Magus, magic, natural philosophy, and religious reform in the Middle Late Ages. Abstract. This article analyzes the 15th century attempt by the Dominican order, especially in Cologne, to win canonization for the 13th century natural philosopher Albert the Great. It shows how Albert's thought on natural philosophy and magic was understood and variously applied, how the Dominicans at Cologne composed his vitae, and how the order's observant movement participated in these developments. It situates the canonization attempt at the intersection of two insignificant trends in which the order was a leading participant. First, the late medieval efforts to reform Christian society beginning in the religious life of monks and mendicants. Second, the increasing concerns about the practice of learned and demonic magic that laid groundwork for the witch hunting of the early modern period. The article aimed to shed light on intersections of science and religion, their apprehension and negotiation, at a decisive moment in European history for both fields of human endeavor. Okay, so, well, you know what? We didn't see it. Check out the preview. Albert Magnus or Magus. I read that by David J. Collins. This article, we already read that. Introduction. The 13th century Friar Albertus Theotnasius was a source of enormous pride for his fellow Dominicans in the later Middle Ages. This was especially true for his confreres in Cologne, where he... Oh, that's all they're going to listen. Okay, well, we tried. Okay, so the next one would be Cornell.edu. That's a PDF. From magic to chemistry and physics. In all the earliest developments of human thought, we have found a strong tendency to ascribe mysterious powers over nature to men and women, especially if they're skilled. Survivals of this new view are found to this day among savages and barbarians left behind in the evolution of civilization, and especially is this the case among the tribes of Australia, Africa, Pacific coast of America. Even in the most enlightened nations still appear popular belief, observances, or sayings drawn from earlier phase of thought. Between the prehistoric savage developing this theory and therefore endeavoring to deal with the powers of nature by magic and modern man who has outgrown it, appears a long line of nations struggling upward through it. As the hieroglyphs, cuneiform inscriptions, and various others of antiquity are read, the development of this belief can be studied in Egypt, India, Babylonia, Assyria, Persia, and Phoenicia. From these civilizations that came into the early thought of Greece and Rome, but especially into the Jewish and Christian sacred books. Both in the Old Testament and the New, we find magic, witchcraft, soothsaying, constantly retrieved. Okay, so As you can see, you go ahead and you could go ahead and look that up yourselves. The philosophy of natural magic and Renaissance science. So as you can all see, that black magic and science used to be black magic and natural philosophy used to be something common, like they were relative, right? So in nowadays, okay. So if you look back then, you could. So there's a problem with this whole Babylonian crap. It's all Babel, okay. So back then, it was fine to have natural philosophy and black magic, to the point where the Catholic Church itself was like, okay, that's it. No more. No one can do it no more. I'm pretty sure they had a bad punishment for that, and depending on who you were, your stature, I mean, in society, who you are, how important you were, and if you got caught doing that, what would happen? So, as we can see that's totally something relative. So nowadays we have what you would call, as we can see that we've already looked this up all the way back to the definition. So we'll go back to dark energy again. So dark energy, it's fine to say you have dark energy when you're talking about mainstream science, right? So now we're going to come back to the quantum vacuum. Because basically, you know what? Let's back up real quick. Quantum vacuum, dark energy versus quantum vacuum. Does dark energy spring from the quantum vacuum? Space.com. Let's check this out. Here we go. It says, observations of Planck and other satellites help to solve the equation of state of dark energy. Image, credit, ESA, and it's a fucking cartoon. Hilarious. It was in 2014. It's pretty old. Almost, 11 years old. The mysterious dark energy that's driving the universe's accelerated expansion may have its roots in the background vacuum energy that pervades all the cosmos, a new study suggests. What we think is happening is a dynamic effect of quantum vacuum, a parameter that we can calculate. That's hilarious. Co-author Joan Sola of the University of Barcelona, Spain, said in a statement, nothing is more full than the quantum vacuum, since it is full of fluctuations that contribute fundamentally to the values that we observe and measure. Though dark energy constitutes about 75% of the universe, scientists don't know exactly what it is. They've developed several different ideas, including the theory of quintessence, which proposes a sort of anti-gravitating agent that repels rather than attracts. Another concept posits the existence of a phantom field whose density continues to increase with time. This theory predicts an accelerating expansion so powerful that it will eventually break apart the bonds that hold the atoms together, tearing the universe apart in a big rip about 20 billion from now. The quintessence and phantom field hypotheses are based partly on data gathered by NASA's Wilkinson's Microwave Anisotropy Probe, the WMAP, and the European Space Agency's Planck satellite, spacecraft that have studied the cosmic microwave background, the ancient light that began saturating the universe 380,000 years after the Big Bang. Excuse me. In the new study, Sola and the lead author Spyros of Basilakos the Academy of Athens in Greece analyzed the same spacecraft observations and find less support for either quintessence or the phantom field idea. Our theoretical study demonstrates that the equation of the state of dark energy can simulate a quintessential field or even a phantom field without being one in reality. Someone said, thus, when we see these effects in the observations from the WMAP, playing, and other instruments, what we're seeing is a mirage. So I'm gonna stop right there with that one, so you guys can go back on that, later on and look that up. Wow, that was so stupid. You guys can look it up on your own. Okay, so as you can see, this whole darkness and dark energy and that is basically the same as black magic. Okay, in the sense that they're both powers, and then by you fear mongering and telling people this and that, you're able to sell this ideal concept to people. You can write books about it and all kinds of other weird stuff. They'll be like, it was peer reviewed. The masters, they're like, yeah, this master said it was peer reviewed by the other masters. All the masters agreed. Yes, master. Okay, so now moving forward, we're going to move back. Move back forward, okay? Okay. What we're going to do right now is we're going to back it up. I'm going to dissect it. Now that you guys have seen that, all of that information that I've showed you, we're going to re-dissect all of this. Okay? Here we go.
We take it for granted that our universe contains planets, stars, and galaxies because those are the things we see. But the only reason these big structures exist is because of the nature of nothingness, empty space.
Okay, there's no such thing as nothingness. Even if you were to try to think about nothingness, you would have to think something to try to justify nothingness. There can never be a nothingness. Next.
But to understand why, we have to go back to the beginning. The very beginning. The Big Bang. I always thought that in the Big Bang...
Now, the Big Bang was made by Lemaitre, priest George Lemaitre, who was a Catholic Jesuit priest, and we just went over about what they believe in.
The observable universe started as a point and then just expanded steadily, more or less, to the point...
Okay. It's expanding. Oh, darn it. Sorry. Okay, so...
Started as a point and then just expanded steadily, more or less, to the point...
Okay, so... Let's back up on expand. Expanding. Become or make larger or more extensive. Okay. So, now watch this. Physics. Undergo a continuous change whereby, according to theory based on observed redshifts and galaxies receding from one another. Okay. Right? To open up, enfold, increase the extent of number. Right? That's fine. We get all that. How to measure something up. Expanding. As you can see, they'll be like that they're measuring the expansion, measuring the expansion, measuring the expansion, measuring the expansion, right? Physics. Well, they keep going back to they're like literally trying to push so hard to push us to like look up that something is expanding in the universe. I didn't say astrophysics. Expanding physically. Wow, this is ridiculous. And it keeps going back. Wow, ridiculous. They're trying so hard to stop. So you can see this expand is a simple one. As you can see, there's that red line. Now you know this is expanding because every so often you go and check, and that red line has expanded, right? Okay. So balloon expanding. So you know a balloon is expanding. This is ridiculous. So you know a balloon is expanding. Okay. There it goes. Finally. It took forever to find this. Wow. I used this a long time ago on everyone. So cosmologists claim the universe may not be expanding. And we can see that's a balloon, and there's nothing that's on the outside of the balloon. Now they know how it's expanding because they'll be able to like see the edge of the balloon, right? So you're on the inside, you can see the edge. Now, if that's the case, then beyond all this edge, there's something like, what is beyond this edge, this line? What is beyond that edge? What is beyond? If this is expanding, it's expanding within this square. On this cartoon right here, it's expanding within the square, right? But then this square is within, the window of the image we're watching. And the image you're watching is within the square of your phone. And your phone is within your hand and your body, and you yourself, you're holding it, or your laptop or your computer. You're sitting there, you're sitting on a desk. All of that is contained in a room, or, in the house, right? And then the house is contained, and so forth and so forth and so forth. Everything is always contained. When you start like looking into geometry and you try to make it this materialism, where you're like, oh yeah, like look, this is it. We're expanding. Oh, now it's expanding even more. Oh look, see, now we know it's expanding. Oh, it's expanding even more. Then you got to question what's expanding within. For you to say that the cosmos or the universe is expanding, okay, it's expanding. Now, when someone sits there and tries to say, look, yeah, they're redshift, it's the redshift, I could point out blue shift and purple shift, okay, or violet shift, whatever you want, however they want to call it, okay. There's a blue shift, and there's on top of that, the Andromeda galaxy supposedly headed right towards the Milky Way galaxy, according to them. So how is it that we're expanding? We wouldn't be expanding because it's headed towards us. If everything was expanding, no galaxy would be headed towards the Milky Way galaxy. Again, everything that's expanding must be contained, as we can see right here. That's how we know that something is expanding. We're able to relatively measure it periodically to know that there's expanding. And by that, I mean the edge. Okay? Now, when you look up into astronomy, we could go ahead and read it right here. It started with a bang and has been expanding ever since. For nearly a century, this has been the standard view of the universe. Now, one cosmologist is proposing a radically different interpretation of events in which the universe is not expanding at all. In a paper posted on the, Arxiv preprint server, Christoph Wetterich, a theoretical physicist at the University of Heidelberg in Germany, has devised, again, as you could see, that's literally like a religious organization. Christoph Wetterich, okay, has devised a different cosmology. Oh, you know what? And to be honest, most of the best astronomers, even a lot of the astronomers from NASA, they're actually Jesuits. They're absolutely 100% Jesuits. They went to Jesuit schools. Okay. So moving forward on this, so in the paper posted on the Arxiv preprint server, Christoph Wetterich, a theoretical physicist at University of Heidelberg in Germany, has devised a different cosmology in which the universe is not expanding, but the mass of everything has been increasing. Such an interpretation could help physicists to understand problematic issues, such as the so-called singularity present at the Big Bang, he says. So even under their own on a positive, even under their own hypothesis and their own theories, there could have just been nothingness and then something had started. There had to be at least a singularity. There had to be something there. Something had to have been there. It couldn't have been just complete nothingness. Like something had to have been there. So although the paper has yet to be peer reviewed, none of the experts contracted by the Nature dismissed it as obviously wrong, and some of them found the idea worth pursuing. I think it's fascinating to explore this alternative representation, says Hongxing Sao, a cosmologist at the University of St. Andrews, UK. St. Andrews? Just so. His treatment seems rigorous enough to be entertained. Astronomers measure whether objects are moving away from or towards Earth by analyzing the light that their atoms emit or absorb, which comes in characteristic colors or frequencies. When matter is moving away from us, these frequencies appear shifted towards the red, or lower frequency, part of the spectrum, in the same way that we hear the pitch of an ambulance siren dropping as it speeds past. In the 1920s, astronomers, including George Lemaitre and Edwin Hubble, found that most galaxies exhibit such redshift, and the redshift was greater for more distant galaxies. From these observations, they deduced that the universe must be expanding. Okay? Now, let's just keep reading. Red herring. But, as Wetterwich points out, the characteristic light emitted by atoms is also governed by the masses of the atoms, elementary particles, and in particular, of their electrons. If an atom were to grow in mass, the photon it emits would become more energetic. Because higher energies correspond to higher frequencies, the emission and absorption frequencies would move towards the blue part of the spectrum. Conversely, if the particles were to become lighter, the frequencies would become redshifted. It's hilarious. This is hilarious, guys. Because the speed of light is finite. When we look at distant galaxies, we're looking backwards in time, okay? Seeing them as they would have been when they emitted the light that we observe. If all masses, that's under the assumption that light is traveling. Now, there's a lot of science experiments where light can be like, looks like it's traveling at a certain speed. It slows down when it hits like a medium, like gel, or water, or something where it slows, or crystal. It slows down. Then when it exits the crystal, of course refracted, it again starts moving, but it accelerates. It accelerates like it's trying to catch up on whatever movement it was hindered. It tries to catch up as if it springs forward after it comes out of any medium. Okay? So back to the reading this. Because the speed of light is finite, okay, when we look at distant galaxies, we are looking backwards in time, seeing them as they would have been when they emitted the light we observe. If all masses were once lower and had been constantly increasing, the colors of old galaxies would look redshifted in comparison to current frequencies, and the amount of redshift would be proportionate to their distances from Earth. Thus, the redshift would make the galaxies seem to be receding, even if they are not. Now, work through this mass in this alternative interpretation of redshift, and all cosmology looks very different. The universe still expands rapidly during a short-lived period known as inflation, but prior to inflation, according to Wetterich, the Big Bang no longer contains a singularity where the density of the universe would be infinite. Instead, the Big Bang stretches out in the past over an essentially infinite period of time, and the current cosmos could be static or even beginning to contract. Now, if you don't understand what static means, there's a steady state. Before this whole Big Bang, excuse me, before this whole Big Bang got all famous and all that because of the Jesuits, um, you can look up that the main model was the steady state model, which was a static model. That's what it was called, static. Static means it's just it's there. I mean, there's no creation to it. It's infinite. So let's move back. You guys can come back to this and read it yourself. Okay, that's cosmologist claims universe may not be expanding, and we'll go back to the date that it was written. So it was written July 16th, 2013, almost 10 years ago. I would say, 11 years ago? Okay, so moving back. Okay, moving back. Let's go ahead and dissect this.
We take it for granted that our universe things we see. But the only reason these big structures exist is because of the nature of nothingness, empty space. But to understand why, we have to go back to the beginning, the very beginning, the Big Bang. You know.
Now again, this all came from Lemaitre. Okay, he's a Jesuit. Jesuits have no reason to try to get you to hate the church or anything like that. What they're actually doing is getting you to follow their belief system. All right, and that belief system includes this whole darkness. That's something that that the Jesuits actually worship.
I always thought that in the Big Bang, the observable universe started as a point and then just expanded steadily, more or less, to the point that we're at today. But that's not actually how it happened. There were 4 different phases in the universe's expansion. To start, it was expanding steadily. But then, after just a tiny fraction of a second...
Again, see how it's expanding? There's that edge. How would they know? There is no way to measure this. This is totally hypothetical. And he is standing beyond this edge, talking and explaining it. I mean, if you stop and think about it, that's like, you know what I mean? Like, oh yeah, some of the presents. So, that's like him standing by and like him being godly, like explaining reality, and it's this bubble. It's just it's expanding, and he's the one standing outside of it, watching it expand. He can hold it in his hand, basically.
The expansion just blew up, and the whole universe increased in size by like 10 to the 26 times in a very short period of time, and that period is known as inflation. And then, just as abruptly as it began...
Okay, so inflation is based on the quantum flux. No, I'm just kidding. That's hilarious. So if you know what the quantum flux is, the quantum flux is the one from back in the Back to the Future, the movie Back to the Future is the quantum flux. But that's actually like them making fun of this nonsense that this guy's talking about right here, the quantum fluctuation. Now, when you look up the quantum fluctuation, it appeared. It wasn't part of the singularity. It appeared externally from some other space and from somewhere else, because it's before space and time even is relative. So this quantum fluctuation appears in a vacuum where no space and no time exists, and it appears inside of this nothingness, which also is imaginary, and then the inflation occurs.
And inflation stopped. And after that, the universe continued expanding, but at a decreasing rate. So the expansion of the universe was actually slowing down, which is exactly what you expect if the universe is full of massive objects that gravitationally attract each other. But then about 5 or 6...
Now, how is mass being produced? This is ridiculous. The more it's expanding, how is more matter being created?
Billion years ago, the expansion of the universe started speeding up again. And this is thought to be caused by dark energy, an energy tied to...
This is thought to. Like, oh. So basically you have an imaginary scenario, and then you have to think about, how would that work? Well, I think this would work.
space. So before that time, there was enough matter, the matter density was high enough, that it was pulling everything back together, slowing down the expansion. But once the universe reached a critical size, well, then there was enough dark energy to start pushing things apart. And that is the phase that we're still in. The expansion of the universe is accelerating. Now, this story doesn't really explain the formation of galaxies until you tie in the...
If everything's pushing apart, then nothing would have formed. And if everything's pulling together, everything would have crunched.
Nature of nothingness. Now, ordinarily, we think of everything around us as made of particles, of atoms and electrons, but our best theories of physics are actually field theories that say all of these particles should be seen...
I've already explained to everyone, you cannot quantify a field
as just excitations in fields. The word field always gets me because it makes me think of, well, fields. But a field is just something that has a value everywhere in space.
A value everywhere in space. But then when you go to ask, well, how big is space? They'll tell you that it's 13 point something billion years. Okay, then when you're like, what's beyond that edge? Well, there's no space. Okay, then what's beyond that? That's when they claim that there's a magical nothingness, okay, beyond the edge. I get the globe ads on this all the time. Look how, look how they show it's flat right there and there's an edge. Now watch how they clean. This was 6 years ago. This is why I make fun of them, of everyone on Facebook with this.
So every subatomic particle has its own field. An electron field, an up quark field, a down quark field, a neutrino field, and so...
Exactly. Look, beyond, before that, explaining that, okay? So when you start talking about like electrons and, okay, look, the electron is not real. The electron is basically like a bit. Okay, when you're like, what do you mean a bit? So when you think about the internet, okay, you can buy and sell the internet now. You can actually, you're able to, purchase data plans and whatnot, right? That's information. Information is sold in bits. Okay? So your IP address is based on bits. Those bits are on octets. Those octets are your IP address. That's how and your MAC address as well is based on binary. Also they're not octets, but they're in pairs. They're binary. Okay. Now these bits of information can be quantified to become bytes. Hence you have megabytes, gigabytes, terabytes. You're able to sell information because you're able to make up a hypothetical measurement of the data that's being able to be transferred. Do you guys comprehend this? Okay, a bit is not really real. Okay, there's no such thing as you don't really have a gigabyte. Okay, you gonna reach out and grab a gigabyte. A gigabyte is a concept. In order for someone to sell you something, okay? That's the problem with this atomists. Atomism is based on selling ideas that can get you to do other things in the long run, okay? Now, when they in order to sell something, you have to be able to cut it up, chop it up, and to sell it. You just, like everything that you go to sell, you have to be able to chop it up down to a small bit that you'll be able to sell. Hence, we have bits of information, which is, the terabytes, gigabytes, and whatnot. Okay? Same thing. The photon, okay, that's how they're able to charge, literally, pun intended, charge you money. Okay? So all of this atomism and all of these virtual particles are basically intended just to not intended, but they're tools used to sell specific energies, basically, because these are energies, right? Telecom, data, that's when you sell it in bits of information. Okay, you guys see what I'm saying? That's a form of energy. Now, when you can control energies like that, you control power, right? So controlling energies, controlling power, controlling telecom, that all comes together. Now, the Jesuits didn't stop with indoctrination. Rather, they literally infiltrated every critical part of society. Every industry that they knew that they could use to gain power, they infiltrated it. All right. So moving forward.
So on. And anywhere there's an excitation in this field, that is some energy in the field, well, that is where we will observe particles. So out in completely empty space, well, the values for all of these fields are basically zero. But here's the thing. It's impossible to make a field perfectly flat and zero.
You cannot take a quantum field and make...
Listen to this idiot, okay? First of all, you cannot take a quantum field. Of course you can't take a quantum field. You can't grab it. You can't quantify it, dumbass. I just explained all that, right? To everyone? Okay, so you can't quantify a field. You can't grab it. You can't touch it. Just like you can't touch space-time. They're like, oh yeah, what is space? Well, time distorts space. Space distorts time. And they say the dumbest things. But you can't grab space and distort it. You can't grab a piece of space, twist it around, tear it apart. You can't rip up time. You can't rip up space. Those concepts are just, that's unrealistic all the way around. All right? It's one thing to use these concepts for monetary purposes, but it's a totally different thing when you start like twisting people's minds around. We're like you're trying to make them dumb. Now look at this idiot as he sits there and holds on to the celestial sphere. By the way, you guys, no, that is not the globe Earth, okay?
Completely quiet. You know, it's the Heisenberg uncertainty principle. It says you can't take a particle and pinpoint it to exactly zero energy. Likewise, you can't take a quantum field and make it exactly flat everywhere.
Now, this is important because ordinarily these fluctuations...
Well, you can't take a quantum field and do anything with it. The best you could do with any type of field is convert one energy to another, and that's it. How hard is that to understand?
Fluctuations are really, really tiny, and they only affect subatomic processes. But during that period of inflation, the universe expanded in size so rapidly and so incredibly that those tiny fluctuations got...
Whoa, you think, look at him stressing to think that his imagination is, I see a globe in my head, I'm so fucking stupid. He's holding like an imaginary globe in his hand. Oh!
Blown up to the scale of the observable universe. Now, without them, we think the matter distribution in the universe would have been completely homogeneous, completely uniform. And that means the gravitational force on any object in the universe would have been the same in all directions, which means nothing would ever have collapsed into the big structure.
Again, I'll cite all of the Principia, and you know what I mean? Like, it's just God this, thank God is great, God is the awesome. You guys heard it. I read it. Okay, Isaac Newton there's no shame in him at all. Like, he is hardcore, man. Like, science, thank God. And I mean, if it wasn't for God, we'd have no science. We would be stupid, man. God is so smart. God is great. Straight up. That's what Isaac Newton said.
That we see today. But thanks to these fluctuations, there were slightly denser and less dense regions, and of course the denser regions had stronger gravitational fields, so they pulled in the matter from around them, and that clumped together the matter into huge gas clouds that would go on to be the galaxies that contain the stars and the planets and the things we know today.
Amen. Praise the Lord.
You can actually see the imprint of these quantum fluctuations in the leftover radiation from the Big Bang, the cosmic microwave background.
Oh, another celestial sphere. Look at that. Look at the colors, yo. It's the colors, and it's a ball. Look at it, but it's oblate.
Background radiation.
The quantum fluctuations in the fields were amplified to big classical fluctuations in the density of matter from place to place.
Hold up your spear a little bit higher, bro.
And those fluctuations in the density of matter show up in the universe
today
as temperature differences in the
nice globe, yo! Globosphere.
Like stars and planets and galaxies.
I think it is incredible that without these fluctuations
That globe makes me feel great, yo. Like, even if it's not the globe Earth, it's like the celestial sphere. It's still a globe. Like, whoa, bro.
in the vacuum, these tiny,
Do you guys even glow, bro? Do you even glow, bro?
insignificant things that we take for granted, our universe might really contain nothing. Nothing of interest, anyway.
Okay, so what did we learn today? Quantum vacuum. Empty space is not empty. Dum. Quantum field theory visualized. Oh, we're gonna visualize this with some CGIs. Vacuum energy. Duh. Living in a quantum dream. I swear, look. Okay, who created nothing? Who created it? Come on, Globestars. Think. Okay? Who is the darkness? Who is the darkness that creates everything, Globestars? Do you guys even science, bro?